We often see images of space, but how do massive objects truly interact with it? Today, you will learn how large objects warp spacetime and how this effect creates gravitational lensing. We will first explore spacetime as a fabric, then see how mass bends it, and finally discover how light gets redirected. Imagine spacetime not as empty void, but as an invisible, flexible three-dimensional fabric. This fabric combines the three dimensions of space with the single dimension of time. When a massive object, like a star or planet, is placed on this fabric, it creates a dip or a curve. This dip is what we call spacetime curvature. The more massive an object, the deeper the curve it creates. What we feel as gravity is actually objects following these curves in spacetime. Like a marble rolling into a bowl. Even light, though it has no mass, must follow these curves in spacetime as it travels. When light from a distant source passes near a very massive object, its path bends along the spacetime curvature. This bending of light by a massive foreground object is called gravitational lensing. Gravitational lensing can make distant objects appear distorted, stretched, or even create multiple images of them. Let's consider an example. Imagine a very distant galaxy located directly behind a huge galaxy cluster. The light from that distant galaxy travels towards Earth, but first encounters the massive galaxy cluster. The immense mass of the cluster curves the spacetime around it, bending the light from the background galaxy. As a result, when the light reaches us, the distant galaxy might appear as a bright arc or multiple distinct images around the cluster. Think about this. If a massive black hole were perfectly aligned between you and another star, what would you observe? You might see an Einstein ring, a perfect circle of light from the background star, due to the black hole's powerful lensing effect. You have learned that mass warps the fabric of spacetime, causing objects and light to follow its curves. This fundamental principle, known as spacetime curvature, explains gravity and the fascinating phenomenon of gravitational lensing. By understanding how massive objects influence their surroundings, we gain profound insights into the universe's structure and its hidden components. Generate your own educational videos for free at eduvids.vercel.app.